Good morning everyone. In today's video I'm going to show you how to make a storefront that made out of the previous accumulation of the previous two videos that we have of the division of the surfaces that we studied in the previous two videos, and how we can distribute the adaptive component and make them with the random height. As you can see in this picture, actually I inspired this from the Axiom Telecom. I saw that one of the malls here in UAE, and it's really nice. And you see the adaptive component is the random height distributed on a divided surface based on, like, say 1, 2, 3, 4, 4 rows, and I don't know how much 4 columns, and I don't know how much rows actually here being distributed. So what we really need to do in this video is to create this surface, this U-shape or flipped U-shape, and then you divide the surface. Let's have a look and let's have a go of how we do that quickly in Dynamo. So in the beginning, of course, I'm going to need to make points. I'm going to have the point by coordinates, and I'm going to start, as you see, with let's say basically 4 points, and just as a beginning to make the a point for the required for a rectangle. So we're going to go for a slider here. So I'm going to go a slider number, let's say that's the total width, or you can call it just width, whatever you want. I'm going to call it width just to make up my life easy, and I'm going to give it, let's say, I don't know, 30 meter, and make sure that this is a unit, and the unit for this is metric system, and the type of metric is meter. So I'm going to keep this for a 0, 0, and I'm going to connect this for the X, giving me, as you can see, 30 meters. Here I'm going to give this for another X in here for the third point, and in our case we definitely need to make the other parameter. So I'm going to call it height, which is the overall height of the the elevation or the facade of the store from here to here. So that's basically what we need to make the rectangle vertically standing. Actually, it shouldn't be at the X, it should be in the Z axis. So this guy should have X and Z, and some reason it doesn't make any sense because I have this 13, so just make it 8, I don't know, or 10, I don't know, 12. So I'll go 15, something in between, and the last one is just stayed on the 0 but have an X, so that it has Z value. So that's technically what we really need to model at the current time, which is 4 points represent the overall rectangle for the facade itself. Now that's been said and that's been done correctly. You can go ahead now and model the inside points, and the inside points are actually here. So we really need to define the offset here in the x-axis or in the width direction, and then we also need to define the offset for the height itself. So we need again to define 2 sliders. So I'm going to have a copy of this guy, and I'm going to name it as an offset in the width direction, and I'm going to need another one like that, and I'm going to call it the offset in the height. Let's just have, I don't know what's wrong in here. Okay, let's just have like 5 meter on both sides. That's what I want, and you can control here the details, but I'm just gonna leave them. I don't think we need, maybe, let's say 30 maximum to make this smaller, and same thing here, 30. Okay, but probably we should have done that in here too, just to make this make more sense. I'm not gonna go more than 30 actually. Let's say you can go ahead and pick whatever dimension you want. What I believe it's in here better to make the scale is smaller and easier to be controlled. Anywho, now we have those 2 sliders been ready. Now we need points. So I'm gonna have this point again copied right here, and this guy is basically 0 plus it's here 0 plus the width itself of the offset. So I'm just going to purely add that directly to the x, defining that point for me in here. Rather than, or as compared to this guy here, this point, again, I'm going to copy it. That's the point. It should be the overall width minus the 5. So we need a basic equation of a minus b, where a is the overall width, which is a 30 meter, minus the offset of 5, giving us the x for value for this guy. So something is really terrifying me here. This is 25, and this dude should be, okay, 5. I don't know why this guy look bigger than that, because I think it's closer to the vanishing point anyway, perspective thing. Yeah, I hate that anyway. Alright, now what really we need to do is to copy those two again as they are, as you can see, like that. Alright, and we need to define for them, or provide for them, the height. So the height in both cases will be again a minus b. So a will be the overall height minus b, which is the overall height offset, which is this guy in here. So technically this is the z value for this dude, as you can see, and I'm going to give this guy again the z value for it. So because they are the same, not like this minus the condition. Now a little bit messy, I know, so I'm just going to move those aside because it's now going to be too much to control. And we need a list, of course. The list to contain all those individual points. I don't know how many they are, and I don't care actually. And what do you have to do to go from the beginning? So this guy here, that's 1. And now the boring business. Now this guy here should be here. That's number 2. And then I think this guy, which is here, 3. And then this dude here, 4. Going down to this, 5. You have to follow the sequence. You know, you don't need to jump, otherwise it's not going to be, you know, a fully closed thing, a fully closed polyline. Now this dude, and eventually this guy here, I'll remove this extra point, and then add a polygon by points, and I'm just going to connect them, getting myself a very nice and beautiful U-shape here that represent the facade, that or the part of the elevation or the storefront that you want to design the thing for it. I'm gonna go surface, as long as it's going well. I didn't flex it yet, or I didn't test. I'm gonna go flex by surface by patch. I have the external boundary of the object, and I get myself a very nice and neat surface created. Now we need to flex that guy to see if it's worked perfectly. So I'm gonna reduce the width, and I see it's beautiful. Now I can flex the height, and I'm still seeing it working really nice. Offset for the width, getting it to 5, and then the offset for the height. So it's fully parametric and nice and beautiful. Now what I need to do is to divide that now into a horizontal and vertical rows. So you remember that we designed something for that. So if I get this guy that we designed, I think number 16 or 17, I have no idea, this dude here, or you can use the the panel dot quad panel, I think, for the pre-made package of Lunchbox. You give it the surface, and immediately it's divided by 4 by 4, and making our life like a big mess. What happened in here, that it's ignored the existence of this gap, and it's assumed that the x, that's the y, and provide us with a point. That's totally make no sense, because it doesn't follow the actual, you know, cutout surface or the remaining of the U shape that we have in here. Now that means really a bad thing happening, so I don't need that now. So again, this will give us to the conclusion that we don't need those neither. So we have to turn them off, and we have to think another way to fix this issue, which is basically we need to, again, I'm going to turn off this guy. We need to create or divide that one surface or divide that geometry into 3 surfaces. That's 1, that's 2, and the one in the middle, which requires again us to create extra 2 points. Probably this guy and this guy will be the best if we took them, you know, as a copy, because those are what we really need. All right, you still need those to be stayed because they're going to be the height of the mid pattern. Now what we have is this, which one I have no idea. Whatever we have connected to the Z have to be eliminated actually. So I'm going to take the overall height and give it to the Z again, ignoring this guy here, and I'm going to ignore this guy the same thing or the same way I did. And before I delete it actually, I'm just going to take the A and give it to the, you know, the Z factor of it. So I'm going to delete that and see what I've done, if I'm working correctly, and I don't think so for some reason. That point, I have no idea where it is. This guy is correct. Okay, so this dude, where it is, it doesn't make any sense. I'm just going to delete it. Okay, so let me see the mistake that I've done. Okay, this guy have the X and the, okay, that's why it have two things, and I delete one of them by mistake. Anyway, so I'm gonna get this guy again. So the Z, where is it? That's the height. So I'm gonna give it to here, and the X should be the same, which is this same as this point actually. So yeah, I'm gonna take this here, and that's it. Now we have those points. Now instead of what we have done as a complicated U shape or flipped U shape, I'm going to make a smaller one, an easier one. I'm going to go back to make a list.create, and in the list I just need 4 points. That's what we need, guys. Okay, let's push that in here, and I'm going to go down, I don't know, maybe here. Too lazy to go there. Now 1, that's the starting point. Beautiful. Now the second point should be closer to it, which is this guy. That's 2. Now the highest point we just created, which is this guy, that will be 3, and back to the third point, which is this guy here, I think. Where is it? That's 2, 3, that's 1. Okay, that will be the fourth one here. So this dude here is the actual required to list to make the, you know, the edit poly. You can just, you know, take those 2 things together and place them in here and just reconnect again. That will give us the preview for that rectangle, and then this guy again and give us the preview, creating a surface, and that surface will be, let's call it the left side, I don't know, okay, whatever you want to call it. Now same thing, same technique. I'm just gonna, you know, copy all those guys again, and same technique. I'm just gonna remove those. All right, now we need the second one here. Actually, we need the one before the second one if I'm going to follow the same sequence. So this guy, I'm gonna go with it, the first, then the second. Okay, then the one in the top corner, which should be the third one here, this one, and then the new one, I think this one. Yep. Now that's all. Just connect. It's actually connected, so that's the 2 things. Now we need, as simple as you can see, as really simple as you can see, just we need to surface.divide. I'm going to go to the package Firas 3 that I already did, this one, the dividing surface one, and all I need is to connect this dude here, and now it's, you know, divided in a way much proper condition. So I can go zooming here, take this guy out. Actually I need a slider. I don't know, can we go with a half condition, or we can go with an integers? I don't know. Let me go, it should be integer actually. But anyway, I'm gonna go this guy, and I'm gonna go here. So let's say a number of U panels. It should be integer anyway, I don't know. And here it should be the panel in the V direction. So let's connect them, and let's assume they are 5 by 5. I'm gonna go and give that to the U instead of the default value of 4. Now let's go this guy here again and connect it to the V, and let's put that into a flex. So the U sound okay, the V probably need a bit of more. That's why, as I said, it's really was better to to make this as integers instead of numbers. See? Anyway, so I'm gonna go here for. You notice that there is lots of delaying. That's okay because it works now simultaneously with the Revit itself, and that will cause a serious delay. Again, I'm gonna make this one. Okay, let's say 10 maybe, I don't know. So 10 by 5, as you can see here, and whatever you've done in the left side, you have to do in the right side. Okay, so this guy have to be copied down. The surface will be the same. Sorry, the U and V will be the same. You have to switch the V value only, and you get yourself nice divided surfaces. That's what I love, and really, guys, in Dynamo is like we have the pain of making the previously 2 videos. Now we just need to add our customized nodes, and that's it. That's the randomized one. And I can just have the randomize. I'm not sure if the randomize will create the element for us. What is this? Adding AC element with randomize height. Okay, so what it does, it actually need a list of AC. And what about the other one here? I already added, haven't I? Yeah, this one will take the surface actually and add an AC element with a random height to the surface. That's even better, So probably we don't need, that's a new one. This one is just need a list of architectural elements. Okay, so this is, if you want to go with this one, I need to add the adaptive component list. And let me show you both actually, they're both customized. If I need to do the first one, so I have to go to the adaptive component by points. Okay, so those are my points here, and of course we need a family type. That's one of the node I designed. I wish I remember the name. Yeah, this dude here. So when you do, when you do that, Revit will, go ahead and apply the surface with an adaptive component, as you can see here. And then you need to provide, let me go this one, scary one. Okay, let's go the list of AC elements, and it's gonna provide an adaptive or a randomized adaptive component, but something went really wrong. It's 0.5. 2, the integer of 0.1 and the height name is height. I have no idea what is going on and why it's not running, but anyway, let's see what is it, what's making it really just doesn't work. Let's give us an integer of 0.1. Probably I'll go manual. I'll cancel if anything is wrong here. And am I looking at the back of it? Yeah, I was looking at the back really. So let's run that and see nothing. Okay, so the height, probably we need to give a height parameter to this guy here. Nothing again. That would start really freaking me out. So now let's go property. Let me see. It's actually not a properties, it should be parameters. Right. Yep. Here it is. So let's see what's really making the problem. Height is 1, so it's okay. And it should be starting from 1 to... Okay, that's weird. So the height name is height, it's correct. Intervals has been set to... That's the value for the maximum distortion. And let me run again. And let's go 0.5 as the minimum value. And then run again. Nothing changing. Oh, it's working now. Crazy, isn't it? Doesn't make any sense anyway. Such an errors that might happen with you. It's all the values has already been set as a default, as you can see, and it's not working. I highly recommend it just to save your work, close that file, and then close Dynamo and open it again if this type of a bug happens, with you. So don't get yourself into the problem. Try, doing whatever I've done. Sometimes closing the thing and opening it will solve it for you anyway. Now that guy needed this node, like to the adaptive component to be created in order to create this geometry. Let me see this guy. It's actually adding the AC component, so I can just give it the surface itself instead even before we dividing it. That's even better. Okay, and have our own inputs. Where is it? So here, if I hit run, is it working, or let's make the same headache? Yeah, of course, have to make the same headache. I know my luck. Wait, still working? Yep, I know my luck. So it's still making the same headache. So the surface value, it's already set for, let's say, the U to 10. And the V, instead of 4, I hate my mouse. It makes lots of noise. And that's the second mouse, by the way. The first mouse even making, worse sound when I scroll in. Anyway, minimum height again, 0.5. The maximum is, let's say, 2. The intervals are 0.1. The height parameter, I will call it height. I don't need to do that. Trust me, it should be default. Anyway, now that guys works correctly, as you can see, and it creates for us the required images, and you can see this guy here, or you can use this guy, whatever value you think it's proper, or whatever you think it's suitable. I'm just going to remove that. I'm going to keep it with this one. So all what we need is I'm going to move that, of course. I'm going to make this guy here again another copy, and I'm going to create that as my points, and the family type is an input, so push it away. It's a good habit. It's really a good habit to organize your input and put them in the same place. So that's what we need. And now it should be also on the other side of the universe. We don't need this property anymore, so I'm just going to copy this guy here down, and need the list of an AC. I need a little push to the run here to get another random set down here in the second or in the other part of the Dynamo panel, or the side panel. Now the sides, as you can see, are actually having a randomized panels here, and it goes in the different heights. You can go and change whatever you want, probably the overall height or the minimum height. Make it, I don't know, 0.3. Maybe this will make it 1.8. I have no idea. And again, you get yourself a different set of a randomized distribution here, as you can see. Anywho, so that's been done and that's been said. Now we have, the big issue, which is the one in the middle. So the one in the middle here, the actual panel need to be defined first. So how we define it is the big issue, not really. So let me first cut off what do I have to turn off? Let me see. That one probably, and this one. So I'm gonna run. I don't want to see lots of objects in here. That's better. We're gonna connect them again, don't worry. Now we see this point and this point, that point. Again, we need a list, and we're gonna have one. So that's a list dot create, and we need 4 points again. Now, which is which? I have no idea. So this guy, no. This guy, I think this one. Nope. Where is it? Yep, that's the first one. That's the first one. That's the second one. Now, where is the third? It should be here somewhere. So no. Yeah, of course, the last one. And the fourth is this one. Okay. So now we have this. This list is ready for us, which is the mid one. And of course, you need, I think, those guys again. Just like that. This is my middle thing, and I'm gonna call that middle. Okay, now I have to connect, and I have to hit run, and I'll find myself with a polygon correctly being defined and the surface already. Now you need to go and define whatever you've done in here, you need to repeat. But before, let me show you what if we just copy and we have a look at that. Before we go and divide that into Revit elements, we're just going to go and have a surface, hit run. And that's really scary for me, because if I connect this guy, for example, and cut it off from the point side and go just to compare the points, you're going to see that's terrifying, because it's 5 in here and it doesn't make any sense as the gaps in here. The gaps are really way too big to be defined, and the same as the height is really too tiny. So what we really need to do is to have the U and V for this middle surface defined based on what we have here on the left side or the right side of the thing. So we really need to postpone this guy and for a couple of seconds, and now we need to go ahead and I have to define the actual width of that panel. So I'm gonna go here, have a code block made of side width, let's say A minus B, and I'm gonna call that guy side or mid panel width. Okay, it is basically the overall width. So I'm gonna have the overall width, where is it here, minus, you know, minus B, which is and then minus C, and B and C will represent the width of the offset. Where is the offset? That's 5. So I'm gonna copy it twice. That's B, and then where is it? That's again offset. And you can see now if I hit run, this guy should be, you know, 30 minus 5 minus 5, and it should be 20, which is the distance from here to here. Doing the same, and instead of the width, we have to define the height. Now, the height, which is the overall height of the, you know, the overall elevation, that's 1. And now it should be minus, I don't know how we define that. It's from here to here. That's the overall height. And if I get minus 5, which is the offset of the height, we get the height of this point, and that's what we really don't need. Oh dear Lord, I have no idea. Let me check how that can be done. So if I say A minus B, let's just try that again. Just delete that. Okay, just delete. I have no idea what's happening. Okay, now let's go with the height here of the offset. Here, run. This guy will be, it's calculating for some reason, I don't know what is it. Just let's cancel here. It give us 10, so it's 15. That's the 10, that's the height. We don't want that, we want this, so it should be wait, that's the height. Beautiful. That's the height from this point to this point. Beautiful. So we need to make actual, I don't know, K or C minus open brackets A minus B, where C is the actual overall height minus A minus B. So A is the overall minus B from which is from here to here, giving us A minus B will be the height from this point to this point. Now the actual height of the panel itself will be the overall height minus this value from here to here. So what I need is to get the height again. Yep, from here, and give it to this dude here, and we have to run. So it should be 10 or 5 actually, because it's from here to here, it's 5. That's what it's the actual height of it. But anyway, I'm just going the way, I'm really going the wrong way, because the offset height is the amount of the offset itself. That's really bad thinking of my side. So I should have taken the offset height itself, and that's it anyway, instead of this headache. Anyhow, now we have the distance from this point to this point. So we really need to divide again, or define, it's the something called A minus B here, and I'm defining this, which is AC, the adaptive component width, and I'm talking about the the single unit of the overall. So how we define that, we really need to find it in here first. So I'm gonna go and have A, which is the offset here. Let's go ahead and have the width, sorry. Let's have the offset value. And then how many we have? 1, 2, 3, 4, 5. So it's in the U value actually, or V. I have no idea. V, sorry. So 1, 2, 3, 4, 5. So I'm going to divide that on 5. And let's see if that make any sense. If you run, this is a 5 meters. So if you have, it's actually divide, not a minus. Run again. So it's 1, that's true, because we have 5 panel, 1, 2, 3, 4, 5. And we have 5 meter, so that leaves us with 1 meter for the thing. Now, if I repeat that, and instead of the height, the width, I will go height, and again the same thing. I'm gonna go the overall height this time, and I'm gonna divide it on the other number, which is I think the U, which is 10. So that's what we have. Run, so 15 divided on 10, it should be I think 1.5. the height of an individual panel itself. So now we have the height of a panel here of one adaptive component, and we have the width of it. So if we got that been defined correctly, we can go to use that width and use that height to define the adaptive component for use that height to define the adaptive component width and height, and knows how many panel you have to do in the the bigger panel, or the middle big panel that you have in here. So I will save that first. Now guys, as you can see here, I just added or I'll just define the mid panel width, which is the overall width from this point to this point, and also the mid panel height, and then we depend on the AC width, or the adaptive component width, and the adaptive component height, dividing the overall width on the unit of a single unit width will have, you know, the number of required of the overall, which is 1, 2, 3, and almost 0.3. And the same thing for the height, to know, you know, how many vertical panel you have, and you gotta get yourself in about 20 of them. So that's how we define the U and V paneling for the mid one by defining the AC from, you know, the neighbor one. I just turned off the neighbor one, you know, to reduce the time required for the calculation. And then I add the same thing, the divided surface, guys, and then I added the adaptive component, and then I added the randomize tool, the same thing that what happened here, exactly the same sequence. I'm gonna hit run so you can see, and that should be, you know, works in the middle one. And let's see how Dynamo can actually define. For some reason Dynamo is hanging here. It's giving us lots of warnings, so I'm gonna hit run again for the last time. Okay, now we need to save. I think that's it. We have to save it in this case and close it again, open it again, sorry. Now you can see the benefit of restarting. It's really worked now in a faster way. That's the divisions. Now, in order to see how they work together, you need to collect you know, the one that we already turned them off, the two sides. Hit run again, and you can see that they are working perfectly so far. As you can see, the only one thing is difference here is this, you know, because this is 3.3, that's mean a little bit longer on this side. If I click on this one, and that can be solved because you shouldn't make this, you know, bigger than the overall assumption. So you can just go overall width, you can just reduce the amount of offset, you get the same panel. Otherwise it won't divide, it won't create 1 unit and a half, but rather it's going to stretch it down. You can overcome this issue by, you know, opening this guy and change the range instead of, you know, approximation node, you need to add +1 if you want to make this exactly the same as this guy, and then you divide it. I think it's better if, for the technical reason. Here you have to remove that symbol here, and then add a list made of 1 and then return them. So it's gonna make the exact same height and then leave the rest to get a 4th smaller unit. Again, remove this guy and then add join, list.join, add this join +1, and then to give it to this one. I removed it because I think it can cause some crashes when you give some odd number like 13 or 11. That's why I, you know, goes with this result better than, you know, the available that I can get from the other option. But anyway, for me, that's so far so good, guys. You can have a go and start flexing this and see how it works. And if you have any error jumped in your way, just tell me so we can fix it together. I wish that you guys find this video useful. Thank you very much for watching, and have a good day. Bye bye.